right, well, welcome back. We're going to be talking about some sampling, and proper sampling. Well, the key thing is we have two different things that we're talking about is a population and a sample. A population is basically everyone in a sample or everyone um, that you want to find out the answer from. Okay, so that is your population. A sample is really a set of individuals from the population. Okay, so it's a smaller set of individuals, smaller set of individuals, all right, in the population. And so we take a simple random sample to give everyone an equal opportunity, all right? So everybody has an equal chance to get selected, all right? Now, we have other sampling methods of a population in order to figure out what the population as a whole would be, and that we have sometimes called voluntary and convenience sampling. Okay, so basically volunteer sampling is where the people choose to be involved in the sample. Sometimes you get that when you have email reviews or whatnot. And then you have convenience sampling where somebody just might take a survey of somebody walking down the street. Now, both of these tend to have biases. Now, a bias is when you do not get a true representation of the population, all right? Not a true representation of the population. Now that can happen with simple random sampling. However, with simple random sampling is that everyone has an equal opportunity, so you try to bring down the bias, at least caused by yourself when you're sampling a population. Now, today we're going to talk about is a lot about this bias and how we can do some sampling errors. We know that simple random sampling, when we use random sampling, is the best way to try to bring down bias, but there are other means that can happen when we do some sampling that does bring in some biases. So the key things that you need to know are undercoverage, when some member of the population cannot or are less likely to be included in a sample, all right, calling landlines or whatnot. Non-response bias, when an individual is part of a survey sample but chooses not to respond or cannot be reached. You see this a lot with different uh, telephone surveys and whatnot. This is different than voluntary response, as we said right here. Voluntary response is where people just choose to be in the sample themselves. So they don't respond, they actually do respond, but that also brings in some other biases as well. Then we have response bias, which is a pattern of inaccurate results, wording of a question, interviewer lying, etc., etc., and that would lead to different response biases. And like I said, question, wording, self-reporting, those are response biases that lead to inaccurate results of what your data would be. So let's go through some quick examples of different sampling measures that are not simple random sampling and why they would bring in some biases. So identify what is wrong with each of these surveys. Be sure to explain what you have here. So the mayor of Springfield is interested in finding out an average age of people in the city. So we're trying to find average age. He obtains a list of all landline telephones that can contact us and then contacts a simple random sample. Okay, so he does just of landlines. He uses data from the sample to estimate the average age of all people in the city. So all people in the city. So the key thing when you're looking at sampling and biases is you want to know what the population you're talking about. Well, in this case, we're talking about all the people in the city. Okay, so that's our population. So he's trying to find information about this. However, he does take a simple random sample, which is good, but he's only using landlines and telephone. Well, if he's only using landlines in the city, does that reach all the people in the city? Does everybody in the simple random sample have the same opportunity to get picked? And the answer is no. As we set it up here, what do we have? Well, right here, we would have an undercoverage bias. And the reason why it would be undercoverage is that landlines, not everybody has a landline phone. Not all people in the city have a landline. So a lot of people probably wouldn't be able to reach because they may have cell phones or whatnot. So there might be an undercoverage especially now in this day of their survey. Or their sample, I should say. Do you think that the mirror would have an over or underestimate the true mean age of the people? Chances are probably be an overestimate. I'm guessing an overestimate. The reason why is because older people, older individuals usually have landlines. And that's what we know. And that I would probably say is true using a little common sense there. Now, here's another example. Administration at a school wants to know the proportion of students that did all their homework last night. So all the homework. So they select a random sample of 100 students and send an email to each of them, asking if they did all their homework last night. All right, so they send it via email. So once again, they do a simple random sample. Okay, a simple random sample, and they want to know what's the population. They want to know of students in the school. So all students in the school. All students in the school. So that's our population. And they send out an email to 100 of the students. So simple random sample of that. Of the 40 responses, 36 of the students said, so they only got 40 responses. Okay, so only 40% of the people responded. 36 of the students said they did all their homework last night, which is 90%. What is wrong with this survey? Well, right here, if you're looking over here, this is probably going to be response bias, okay? We could also say voluntary response sample also. And so this is probably a voluntary, all right? Voluntary and probably some response bias here. And when we have this for our things. Do you think the mystery will over or underestimate? Well, I'm guessing this would be an overestimation, because probably you might be thinking overestimation of how many people did it, because the people that actually check their email, those students, probably are doing their homework. Okay, so because I know a lot of students don't check email, so this is probably overestimate, only with students that check email, which means they may also do their homework. Do their homework. All right. And I'll just go HW for homework. All right. Well, one final one right here. We have a Boy Scout leader, Peter, wants to know the proportion of people in his neighborhood, so in his neighborhood, who support Boy Scouts. Okay, so the population is his neighborhood. Okay, so that's our population. He takes a random sample of 30 homes and visits them dressed in uniform. Oh, okay, so dressed in uniform. What is wrong with this survey? Well, this would be, once again, some response bias. If somebody came to your door, and once again, though it was a random sample, okay, a random sample of 30 homes, even though it was a random sample, but he came to your door and he tried eliminating bias, but he was dressed up as a Boy Scout, would you give a bad review of the Boy Scouts? So this would be response bias. Probably would give probably a favorable review. Do you think people overestimate? I think it would be overestimate. Overestimate as people would not want to report negatively to him as he looks like a Boy Scout. All right. And is involved with that. All right. And that's what we have right there. Okay. So I hope this helps you out. We're going to go through some more sampling errors and whatnot and how we can have this, but some basic examples of where we have biases. We want to do a simple random sample, but even as you can see right here, I said this is great, but even with this simple random sample, we can still lead into biases. Either we can have some undercoverages, we can have some non-response biases, and even some response biases depending on how we present the simple random sample. So this doesn't lead to it. It is not foolproof, so it's important that we take into these other factors as well. Things that we want to really avoid are voluntary and convenience sampling. That gives us much more bias, okay? In any case, it's important that we understand how to take a proper sample of a population so our numbers do match as close as we can to what actually the true population would be. All right, well, we're going to talk about this some more in some other videos, but good looking out less than the rest of your problems.